Hello everyone, myself is Vijay Kumar Kamble, Assistant Professor, Department of Electrical Engineering, All India Sri Shivaji Memorial Society's Institute of Information Technology. Today we are going to see the topic per unit system. So in power system there are lot of components devices are present. Power system calculations can be made by taking either the actual values of different quantities or the per unit values. Taking the quantities in per unit system simplify the calculations to a great extent. It is usual to express voltage, current, volt amperes, and impedances of an electrical circuit in per unit base are reference values of these quantities. In simple words, a per unit system is converting the system quantities into uniform normalized platform, which makes the calculation simple. As all of you know that in power system, with the help of step down transformer, different power equipments with different voltages and power levels are connected together, but these as these are at different voltages and power levels, they cause problem in finding out the currents or voltages at various points in the network. To solve this problem, all the system quantities are converted into a uniform normalized platform using a base value, and this is nothing but the per unit values. So power system calculations are made in two ways. We can do the calculation by taking the actual values, but if I take the actual values, it will take a long time, or the calculations will become complex, because all the devices, all the equipments which are there in the power system are having very large rating in megawatt, MVA, kiloamperes, kilovolts, like this. So you are getting a very large number, and to do the calculations, to do the analysis with a large number, so it is very difficult. It is very tedious job, and there may get some error also. So generally, all these values are converted into a per unit values. So how to convert a per unit values? So per unit value, in per unit value, we are considering a base value. Any arbitrary value will be considered as a base value, and per unit value will be calculated as actual value divided by the base value. So if I take the quantities in per unit system, it will simplify the calculations to a great extent, and it is usual to express voltage, current, volt amperes, and impedance of an electrical circuit in per unit of the base or a reference value of these quantities. So in simple words, a per unit system is converting the system quantities into a uniform normalized platform, which makes the calculation simple. As per unit quantity is defined as actual value divided by the base value, that is, both the quantities in the numerator and the denominator are having the same quantities, so same units. So per unit quantity will be a unitless or dimensionless. So per unit quantity defined as it is the ratio of actual quantity to the base value of the quantity. So if I have to define a voltage in per unit, voltage per unit is given by V actual divided by V base. If I have to define a current, current per unit will become current actual divided by current base, that is I actual divided by I base. SPU, that is apparent power, is given by S actual divided by S base, that is actual apparent power to the base apparent power, and Zpu is given by Z actual divided by Z base, that is per unit impedance is given by Z actual, that is actual impedance divided by the base impedance. So let us see the per unit calculation of a single phase system. To calculate the per unit impedance of a circuit element, first we need to find out the base impedance. So generally in power system, base MVA and base kVA ratings are given. Then base current can be calculated as base current in kiloampere will be equal to base MVA divided by base kV. Base current in kiloampere can be calculated as base MVA divided by base kV. Then base impedance can be found out by using the rule or using the formula. Base impedance will be equal to, that base impedance will be in ohm, that base impedance will be given as base kV divided by base kiloampere. As we know the base kiloampere, I will replace this base kiloampere by this equation, then I will get base impedance will be base kV, which will be here, and base kiloampere will be replaced by base MVA divided by base kV, that is base MVA divided by base kV. From this I will get the base impedance or Z base will be equal to base kV square divided by base MVA. So by using this formula you will get the base impedance, that is base kV square divided by base MVA. Then per unit impedance is calculated as, per unit impedance is given as actual impedance divided by the base impedance. So Zpu will be Z actual divided by Z base. Now we know the equation for Z base. I will use the equation for Z base in this equation. So Zpu will be equal to Z actual divided by base kV square divided by base MVA. I can simplify this equation or rearrange this equation. By rearranging this equation, I will get Zpu, that is per unit impedance, will be equal to Z actual into base MVA divided by base kV square. So this is the final equation for the per unit impedance, that is Zpu, that is per unit impedance, will be equal to Z actual, that is actual impedance, into base MVA divided by base kV square. Thank you.